We discuss heat and work in this chapter. Heat is a form of energy. When two bodies at two different temperatures are kept in contact with each other, then heat transfers from higher temperature to lower temperature. So heat transfers from high temperature to low temperature. So this is the body at high temperature. This is the body at low temperature, or we can say this is boiling water. This is water at normal temperature. Then these two are connected by a side tube. Therefore water enters from one container to another container. Then temperature in both the containers become equal. So two bodies are kept in contact with each other. The heat transfers from high temperature to low temperature until they reach the same temperature, that is until the thermal equilibrium is achieved. Heat is denoted by Q. So heat absorbed by the system is positive, that is Q is greater than 0 or positive, whereas heat given out by the system is negative, that is Q is less than 0 or negative. So this is about heat. This is a beaker, closed beaker, in which some water is there, and here this is a paddle wheel. So the paddle wheel is rotated continuously. When the paddle wheel is rotated continuously for some time, water becomes hot. That is, some work is done by paddle wheel. So this work is called mechanical work. Thus the work is of two types. One is mechanical work, and the other one is electrical work. In this, let us discuss about the mechanical work. So mechanical work in the form of PV work. So let us become familiar with mechanical work, that is PV work. PV work means pressure volume work. Now let us see the sign convention of the work. If work is done on the system is positive or work is greater than 0. If work is done by the system, then it is negative or W is less than 0. Work is done on the system means work done on the system means compression of the gas. compression of the gas. Therefore, W is greater than 0. Work done by the system. Work done by the system is expansion of gas. Therefore, W is less than 0. So, derivation of PV work. Consider a cylinder fitted with a piston. This is the piston. This is the cylinder with the gas. Cylinder with the gas. With the area of cross section of the cylinder. Cylinder, say A. This area is A. Now, the pressure, this is P internal. This is here, this is P external. Internal pressure and external pressure. When P internal is equal to P external, then piston does not move. Piston does not move. Piston does not move. If P external is greater than P internal, then piston moves towards the bottom of the cylinder. Therefore, so here the piston moves up to here. So here this is P external, this is P internal. So if the external pressure is more than internal pressure, then piston moves inside. Then what is the volume? What is the change in volume? So this is previously the position of the piston is here. This is the distance traveled. Distance traveled is L. Right. Change in volume. Change in volume be delta V. Change in volume be delta V. So what happens here when P external is greater than P internal? Compression takes place. Compression of the gas. Compression of the gas takes place. Compression of the gas takes place means work is done on the system. Work is done on the system. If work is done on the system, W is greater than 0 or W is positive. W is positive. Therefore, volume of air compressed equal to V final minus V initial. V final minus V initial. This is Vf minus Vi. Now pressure equal to force by area. Pressure equal to force by area. Pressure equal to force by area or force equal to pressure into area. Here pressure means P external into area. What is work? Work equal to force into displacement. Force into displacement. Here displacement means displacement is the distance traveled by or distance covered by piston, that is L. Then what is force? So force here, therefore work equal to force is nothing but P external into area into L. Right, area into L is nothing but P external, area into L is volume. So here volume is volume change. So P external into change in volume equal to P external into delta V. P external into delta V. But in this case, in case of compression, delta V is negative since V final is less than V initial. V final is less than V initial. Right. Therefore, work equal to P external into minus delta V. In case of compression, work is positive. So since work to be positive, we have to take negative sign in the formula. We have to take negative sign in the formula. That is, therefore work equal to minus P delta V. So here minus P into delta V in case of compression is minus. So delta V in compression is negative. Therefore minus P into minus delta V equal to minus into minus becomes plus. So P delta V, therefore W becomes positive. W becomes positive. Right. Even in case of expansion, V final is more than V initial. So delta V equal to V final minus V initial equal to positive. In case of expansion means work done by the system. So work done by the system is negative. Therefore W equal to minus P delta V equal to minus P into delta V is positive in this case. So plus delta V. Therefore this is nothing but minus P delta V. So whether it is a compression or expansion, there will be negative sign in P delta V expression. W equal to minus P delta V. So let us summarize. Heat given to system Q is greater than 0 or positive. Heat given by the system Q is less than 0 or negative. Similarly, for expansion of gases, expansion means or work done by the system. W is less than 0 or negative. For compression or work done on the system, that is work is greater than 0 or positive. So this you have to keep in mind. This is a very important points. So this you have to keep in mind. Right. Just now we derived work equal to minus P delta V. So this expression, this is used in case of single step process. Single step process means irreversible process. Irreversible process. So for single step process or irreversible process, so we have the expression for work equal to work equal to minus P delta V. Now, in case of reversible work, reversible work takes place in multi steps. Just recollect the example of reversible process. In case of reversible process, we had the example, keep 1 kilogram of sand on the piston containing piston on the piston fitted to a container filled with gas. If one speck is removed every time, the change is very negligible, and of course at the same time it reaches to the original position. The piston reaches to original position, and such a process is known as a reversible process. So here this is the container and this is the piston. And here this is P internal, here P external. So P internal is equal to P external. When internal pressure is equal to external pressure, there will be no movement of the piston. Here let us keep a sand. This is a speck of sand. When a speck of sand is kept on the piston, when a sand particle is kept, the piston moves a little bit. Piston is pushed down. The piston moves a pushed. So when a sand particle is kept on the piston is moved down. Therefore, P external is greater than P internal. That's why the piston moves down. How much it is external? How much pressure is more? So the excess pressure is equal to weight of the sand particle. So to balance this, to balance the external pressure, internal pressure increases a little bit. How much increases? P external is equal to P internal plus dP. dP means excess pressure developed. Excess pressure develops. Therefore, P external is less than P internal, because the excess pressure develops inside the cylinder, right? Suppose a sand particle is removed on the piston. So P external is equal to P internal minus dP. Thus P external is equal to P internal plus or minus dP. What is work done? Just now we derived. Work done is equal to minus P delta V. This is for a single step. But in reversible reaction, infinite steps will be there. Infinite steps will be present. That means in every step there is a change in pressure. That is, external pressure is less than or more than internal pressure. So in every step the change in volume is very small and it is dV. Therefore, work equal to minus P external into delta V. This is for single step. For multi-step reaction or process, work equal to, we have to take the sum of the changes of volume in all the steps. Therefore, in order to sum up, we take integration. So, minus V initial to V final P external into dV. So, W equal to minus integral V initial to V final P external into dV. But in the previous step we discussed, we derived that P external is equal to P internal plus or minus dP, So, let us substitute this here. Therefore, W equal to minus V initial to V final, this is P internal plus or minus dP into dV. Since dP, that is change in pressure, is very small, so dP can be neglected. Therefore, W equal to minus Vi to V initial to V final P internal into dV. But what is ideal gas equation? Ideal gas equation is PV equal to nRT. So, P equal to nRT by V. So, let us substitute this value here. Therefore, W is equal to minus V initial to V final nRT by V into dV. So, this is N is number of moles constant, R is a gas constant, and if the process is carried at constant temperature, T is also constant. Therefore, let us bring out these constant terms outside the integral. Therefore, minus nRT integral V initial to V final 1 by V into dV. So, if we find the integration for this integral 1 by V into dV is nothing but, so this is minus nRT ln V from Vi to V final, V initial to V final. So, this can also be written as minus nRT ln means natural logarithm, V final by V initial. Natural logarithm can be converted into Bayesian logarithm by multiplying with 2.303. Therefore, this is minus 2.303 nRT log V final Vf by Vi. So, this is the work done for, so this is the equation for work done in reversible process. So, this is a very important reversible process. In the next module, let us discuss the first law of thermodynamics and different cases for this work done in a reversible process.